So let's get started. I'll turn the lights off because I feel like for today's lecture, it is a little bit more slide based. Nope, should go for day night. Cool. So today we're talking about functions, which is really cool and something that you guys have already been doing pretty much every day since you started boot camp, right? Like every test that you've written, you've basically wrote a function and then you've ran a function and you try to compare the outputs. And you try to see if the outputs equaled what you were expecting, right? So in that way, like functions are something that's very, very fundamental, if not the most fundamental part of programming. Hi. Um,
Sorry.
no, you're good.
I accidentally hit the wrong thing.
You're fine. So functions as loosely defined as possible is just it's any piece of code that does something that you can reuse over and over and over again. And this thing that function does is not only is it reusable, but also breaks down maybe something that takes 20 steps and just makes it a little bit more easier to read and understand, right? By maybe breaking down into 4 functions of 5 steps each, rather than having this one huge monolith of 20 steps. In fact, if you start coding and depending on which environments or tools you use, there will be certain programs that actually tell you, hey, your code is going to throw an error, not because it's doing something wrong, but because it's too long. And there's different ways to how it calculates how long a function is. But having long functions in general are just like bad practice. If anything, as you go through someone's code, you might be wondering, wait, why are they having so many different small functions do all these very, very small nuanced things, right? And as you work through it, it might feel like a chore actually trying to track where the code is going and which function does what. But in terms of kind of building out bigger and bigger projects, as you start building out more and more and bigger functions, you'll realize that having one function that does everything has two main drawbacks. One of which is that it's just that if something breaks, it's not really clear exactly what's breaking a lot of time, right? Like you're putting X in and you expect Y to come out. If Y doesn't come out, you now have like 20 different steps in which something could be breaking. Whereas if you had many small modular functions, you could check after each step to see if each of the individual functions are broken. And the second reason why bigger functions are also sometimes less ideal is because one of the cool things about a function is that you can actually adopt them, right? You can change different functions depending on what it does. And so if you have one function that does 20 things at once, it's really hard for you to go in and change that one function to make it say, hey, can you do the other 19 things the exact same way, but for this one small thing, can you do it a bit differently, right? In essence, if you have one big function that does all 20 steps in one big function, then in order to change that one step, you basically need to copy over this function now and copy 19 more steps just to change the one that you actually want to change. So by making the function more modular, it also gives you the flexibility of having to tweak certain elements of it, without necessarily having to upset the whole apple cart, if you will. Make sense? Kind of. Don't worry, it will. Cool. So this poorly placed arrow here. Okay, so let's talk about what actually what actually a function looks like syntactically in JavaScript, right? So JavaScript, really, the two main things that you think about are you need a function, right, which tells JavaScript that, hey, I'm going to define a function. In most IDEs, if you're writing JavaScript, if you write the word function, it will color it differently, right? So what do we call words that are being held for other reasons in JavaScript? Reserved words, exactly. So you cannot never have a variable called function. For a lot of reasons, you really shouldn't be doing that. Not the least of which is that JavaScript probably will not let you. Okay, so function is a reserved word. Then we have this function name. This function name that we put it here, but you might also see other instances in which a function might not have a name, right? And so I think we saw a few of those yesterday when we were looking at the array methods or methods that could go in arrays. But function name is something that may or may not be optional depending on how you set up the function. And we'll cover the two different ways to define a function later on. Okay, so function name may or may not be optical. May or may not be optional. And then we have these parentheses that tells you, hey, what goes into this argument? What goes into this function, right? What kind of data should I expect to get before I can actually run? In this case, we're feeding in one variable called number. Even if I don't have any even if I don't expect anything to come in, I still need the parentheses there to at least tell us that, hey, don't expect anything. You can just run by yourself without getting any input from outside parties. Then we have these curly braces. And these curly braces are super important because they'll define something that we're going to cover tomorrow called scope. Okay, but for now, just know that this marks the beginning and the end of the actual body of the function. Okay, so on line 1, we'll call it here, right? What we've really done is we said, hey, this is going to be a function, right? I'm going to call it by this name. This is what you should be expecting as input, and that's it. Like that's the basic setup of my function, right? Of like how I define it, what I expect, how it's going to be run, and then everything in between the curly braces here are going to be the body of my function. So what does my function actually do? What kind of code is it actually executing? Okay, using a function. So a lot of times when we write code, right, and I think this happened, I'm probably more towards last week than this week, hopefully. But I know last week we had a few cases where someone would write a function and be like, all right, I'm gonna run my test. They run it, they get back undefined. Nothing comes out, nothing logs out. It's like, what happened? I wrote my function. Why is it not doing what I wanted to do? And the answer to that, as this slide may give you an indication of, is because when you write out a function, when you tell the computer what a function is, it's just like defining a variable, right? You're just telling it, hey, this is what you're gonna be, not go do this, right? What you're really saying is, so if you look at this code here, right, where we define this function called 2+, all this is telling us is, hey, JavaScript, we're gonna have a function, it's gonna do this, and it's gonna be called 2+. That's it. You sit tight. Don't do anything else. Just know that I exist, right? That's it. And so when we write this out, all this does is, in JavaScript, and one of the later slides I can cover this, we have this concept of hoisting, right? Of kind of like what's available to the rest of the page, right? If I define a variable on line 1, I expect you to use it on line 2, right? So on and so forth. And so here, when we write a function, always be very careful about the difference between defining a function and invoking a function. It's something that's actually a lot trickier than maybe this slide is making it out to be. And the reason why is because a lot of times, as one thing that you'll see that you can actually take a function and pass it in to another function, right? And when you pass it into another function, be very careful about whether or not you're passing in the function variable or the function invocation, right? And what all invocation means is, hey, I know what you do, now go do it, right? So how do you invoke a function? Well, you take the function name and you add these open and close parentheses after it, right? Which basically tells it, hey, now you're going to run. One of the things to realize when we look at this invocation function is between these parentheses, you're also going to feed a certain variables. These variables are what we call arguments, right? And the thing with this argument is that this, when you pass in here, should be what you get out of here. In general, to the best of your abilities, always make these two match. In the sense that if someone expects 2 arguments, you should give it 2 arguments. Depending on the implementation of JavaScript, there may be cases where like if it expects like 3 things, right? Like 3 things, right? And you give it like 10 things, like it may or may not throw an error at you. But in general, you want to be able to what you want to be able to do is make sure that you know exactly what the function you're using is expecting, and you want to know what to give it. So this is sometimes called the signature of a function, right? Or the contract, which is what do I expect to get from my previous, what do I expect to get to make myself work? And in this case, it looks like this is expecting a number. Any questions on function so far, or the differences between the definition of a function and the invocation of a function?
But num can actually be anything, right? It doesn't have to be a number.
In this case, yeah. So in this case here, we call it num, but this can be, we can call it foo, we can call it any variable name. Right. This is actually very very flexible. And what's actually going on behind the scenes here, and we'll see this later on, is here we have this thing called num, right? And then we use it in the rest of this function. But what is actually really happening behind the scenes here is between, we'll say, line 1 and line 2, we're actually saying, okay, the argument's value is 5. Let's create this variable here called num and give it the value 5 so that everyone else in this function can now use this variable. Okay, so that's what's going on here. But for the most part, you'll see that this can be anything. You can call this name anything you want as long as I think reserved words are still off limits. Yeah. The other thing to note is that let's just say here we want to have something that does like num plus 2, right? And we expect a number back. In this case, what if I pass it a string? What's going to happen? Right, it will concatenate. So it will not throw an error in the traditional sense, right? Because JavaScript would say, well, you gave me a string and you told me to add something to it, and that's absolutely valid, right? Like I could very well have passed it the word hello, right, and said, hey, can you add to the word world, right? That's perfectly valid. So JavaScript it doesn't know what it's supposed to do, right? It will try to do what you told it to do, and as long as it doesn't throw an error, as long as it is relatively speaking physically able to do it, it will do it. Now, in this case, however, strings have like what like a have they have like a substring function, right? So you can say give me the first and third character, right? So if this was saying, hey, give me your substring and you pass it a number, it's going to try to do the substring and it's going to say, hey, this variable doesn't have a substring property associated with it. You can't do that. And so in those cases, you would get an error. As a programmer, it's actually really good when the computer throws an error at you because then you are aware of what happened and what went wrong. You can work backwards and fix it. What are a lot more deadly are these silent errors, right? Where JavaScript's not going to throw an error. It's going to say, yeah, you told me to do this and I did it and I got no errors. Like, here you go, right? But as a human, you might not actually see what's going on behind the scenes, right? So if this function is called 2 plus and we're trying to get a number and add 2 to it, and if I pass this a string, it will do exactly what it's conditioned to do, which is, in this case, concatenate two things together. It's going to give me back a string. It's not going to throw any errors. And if I was feeding that output directly to somewhere else, I actually never see the fact that I got a string out of this and not a number. So that's why silent errors sometimes are a lot more deadly. And the way around it is, in certain cases where things are not going the way you plan, and this is something that I'll definitely kind of push you guys on tonight when you do the workshop, is to say, hey, at every single step, tell me exactly what this variable is. And if you can't, then it means that you don't understand your code well enough, and you probably need to log out to see what's happening at each individual step. If I point to a variable at any given point in the function and say, what is this, and you don't know, then that's a really, really big gap, because as a programmer, you should always know what's going on in each line of your code, right? Never accept the fact that there's magic code and like I put it in, something magical happens. Like, that doesn't exist. Computers are all Booleans at the end of the day. It's just all true false, right? So if I put something in and you don't get back what you get, or rather, if I put something in this factory in the first step, and then 10 steps later I get back something super weird that's like completely not what I thought it would be, that just means as each individual point, you need to figure out what's going on. And I guarantee you, more often than not, it's because one of your functions is not doing what you thought it would do. Cool. So now let's talk about how we create functions, right? So what we've seen here is kind of what we talked about so far, right? I have my function keyword, I have a name, I have my contract, or I have my argument that tells you, hey, this is what you should be expecting. I have my curly braces, which defines my scope, right? It tells me kind of where my function starts and ends. And then finally, I have my code in the middle that actually runs when I call this function. Pretty straightforward. On the right-hand side, we have something that's also a pretty common principle as well, right? Which is to say that, hey, here I have a variable. I'm going to call it anything I want, right? And what is this variable? Well, this variable is going to be a function that takes in a number. It's going to have the same curly braces, and it's going to execute some line code. So really, when we look at this, like these two, like from lines outside of line 1, everything else looks identical, right? And really, the only thing that's the difference is, in this case, we're saying function and then giving it a name. Here, we're saying is, hey, let's create a variable first and capture this function inside that variable. So why do we do this? Or what are the pros and cons, we'll say, of doing this? Well, now we're going to something called function declaration and function expression, okay? What declaration really does is, declaration just says, hey, like, create a function. I don't necessarily need to store it as a given variable, but I want you to create it on your first pass through. And I'll come back to talk about what that really means. But the other thing about this that's also really important to know, something you can do here that you can't do here, is this second bullet here. You cannot create this in a non-function block. So if I have an if statement, right, it's like if this number is greater than 5, right, create a function. I can write if this number is greater than 5, curly brace. Inside of it, I can create this variable called 2 plus, and I can make it a function. That's totally valid. I can't do that inside this function, in this function, because because in handling, what it does is when when JavaScript compiles, it goes through and sees this. What that does is it basically is looking for an expression to generate this initial function. And if it sees it inside of code that's not basically like, I guess, in the function scope directly, it's going to throw an error or tell you, hey, you can't do that. So this is something that you probably want to do, not nested inside anything else, really. So that's just like a somewhat rule of thumb, really. And I think as you use more, you get a better feel for when and why that's more appropriate. And then the other thing is right here, this idea of this can be hoisted. So is everyone here familiar with hoisting or what it does? No, that's one answer. Anyone else? Cool. So hoisting, I think, is something that's like, it can be a little bit tricky at first. So I'll just go through an example, a live example of it, and then hopefully we'll get a better sense of what it's trying to do here. So let's go to JavaScript. All right. So if I say something like, var foo equals 3. Okay. All right. Okay, so I say something like var foo equals 3, right? And then here I say, okay, console.log out for me. Foo. This works, right? Exactly as we expect it to. However, if I move this line up here and say, hey, console log out for me, foo, what does it do? Well, first it says, hey, foo's actually undefined. And we'll talk about what it means when I say why it's showing undefined. But more importantly, what this tells us is that basically, if I ever want this foo value of 3, if I ever want to access that value, I have to do it after it's been assigned. Right? Everyone see that, right? Like, before this foo variable gets a value of 3, it's undefined. After it gets a value of 3, then I actually see this value of 3. Now let's contrast that to what's going on with the function here, right? So if I say something like, like function foo bar, and I take in a num, okay, and I just return back num plus 1, okay. Here, if I have something that looks like this, I say, hey, foo bar, and I say let's run this function and let's give it a value of 1, assuming I comment this stuff out. When I run this, I'm gonna get back 2, right? Makes total sense. However, if I move this now to the top before this other initial function is declared, I also get 2. And so this is what we mean when we say hoisting, right? JavaScript, essentially, what it does is, the way that JavaScript, or computers, I should say, or browsers, or wherever you're writing JavaScript in, when it goes through a page, what it's actually doing is, it goes through first and says, okay, great, what are all your functions? Sorry, not that. What are all your variables, right? And in this case, this function is considered a quote-unquote variable, right? It goes through it once, so it at least knows what's available on the page, okay? And then what it does is, it goes through a second time and says, all right, for those variables, what are your values, right? So when we look at this up here, lines 1 through 3, to explain the phenomenon we just saw where it was undefined first and then 3. First, JavaScript goes through this page and says, okay, what variables are there? Well, I see a foo, and then I see a foo bar. I'll come back to the foo bar in a little bit, but let's just focus on this foo for now, okay? It goes through the page first and says, okay, I see a variable called foo. Okay, great. That's what I have available on the page. Now let's go through it a second time and let's try executing the line of code, right? I know what variable can be on the page. Now let's go through it and execute the code, okay? First one, console log out foo for me. Well, I know foo is a variable, but I've yet to assign a value yet. So if you put a gun to my head, essentially, and force me to run, sorry, that's probably poor phrasing or poor analogy, but if you force me to say, hey, print out foo, I'm gonna get back undefined because I know foo is an actual variable on this page somewhere. I just haven't assigned the value yet. I then move to line 2 and say, great, now foo is 3. And then when I ask the console log it again, it'll say, I know foo is a variable, and I know I've assigned it a value of 3, right? And if I want to add one more wrinkle here, here, so foo equal, oh god. Typos galore. Okay, so now if I say foo equals 4, it goes through it once. It says there's still one variable called foo, right? I print it the first time. It's going to say you're undefined. Cool. I assign a value of 3. It's going to print out 3. And then I'm going to assign it to 4, and then it's going to print out 4. So you kind of see it executing in order from line to line, right? Does that make sense to everyone? Kind of the order in which this variable declaration is happening?
Yes.
Cool. So what hoisting does is hoisting says, hey, you know that initial step where I at least tell you that foo is a variable on this page? I'll tell you that foo bar is a variable too, but I'll actually just give you the whole function, so that when you start executing code again, no matter where you use this function, it's going to be available, right? Basically, this function gets defined on the first pass as opposed to the second pass that we normally see these variables get defined in. So that's what hoisting does. Okay, so that's why in this, so I'm just going to delete some of this because just so we can see more of the page here. But that's why if I look at something like this, right? Like, foo bar, technically speaking, comes before this declaration, right? But as JavaScript reads, or as the computer reads this line of code, it's going to go through it once and say, hey, what's on the page? It's going to say, I have an undefined variable called foo, right? I know it exists. I don't know what it is yet. And I have this thing called foo bar, but I know where it is. I know it's a function. It's on this page and it's usable. So then when the computer goes back and tries to execute each line of code, it's going to say, print out for me foo, to say that's undefined, I don't know what it is yet. Now execute foo bar, and it'll say, I know exactly what that is, because when I went through the page the first time, I've hoisted this function to the very top of the page, so that any code that's executed on the page will now know what that is and have a reference to it, even though it may come subsequently in terms of line order. Pause for effect. Yes.
I guess that makes sense because it's the logic that that wouldn't work with variables because the variable might change throughout the code,
right?
Whereas the function changes based on what you pass into it.
Exactly.
So if you're going to have the variable there multiple times, you can't assign it a value.
Right.
Unless it's
right. Yeah, and that's a pretty good segue into kind of our slide from earlier, right? Which is that, hey, guess what? The reason why I'm making a big point of this is because you can't do this if you use a variable to declare a function, right? Because like you said, I can redeclare that variable several times, and it can be something new each time. So when I use that variable, I have no idea what it actually is at that moment, right? So let's go back here now. Sorry, function expression, right? We do the same thing, right? And we have a variable name, right? We set equals to function. And see, here's where the name becomes more or less optional, right? I could give it a name, which is totally cool, or I could not give it a name, also cool, right? I'm capturing it inside of a variable, and I'm saying, basically what I'm saying is, as JavaScript goes through this page, it's not going to hoist up this function, right? What it's going to do? It's going to say, hey, I know 2 plus is a variable on this page somewhere. That's it. And then as I go through and execute it line by line, I better make sure that if I'm ever using 2 plus anywhere as a function, that it appears after this declaration, right? So going back to the example we had earlier here, then basically if I have something like var foo bar is equal to this, now if I try to run this function, it's going to not really like me at all. Because what's happening is JavaScript's going to go through and says, oh, great, what's on the page? Oh, great, you have a foo bar variable on the page. That's awesome. And then online, while we're trying to use it, it'll say, hey, look, I know you have a variable there, but I have no idea what it is. And as far as I know, undefined isn't a function. I can't execute on undefined. So therefore, I'm going to throw an error at you. And this error is pretty important. In case you can't see it, I'll paste it over here. But this error tells us that, hey, foo bar's not a function. Right? Like, kind of appreciate what that's telling you. It's telling you that like, foo bar exists. I'm not disputing the fact that foo bar exists. What this computer is disputing is the fact that, hey, I can't invoke it with an argument of 1. Like, this is a part that's foreign to the computer, not foo bar, right? And so when you declare something with the variables, like you are in lines 3 through 5 here, that's really kind of like the bigger the bigger, I guess, risk you can call it that you're taking now is because of the fact that now what you're really doing is now you're basically saying anything that uses this has to come after it on the page in terms of line order, because in order for foobar to be a function, I need to have executed it already before I use it. Pause again for effect.
Yeah, so what, just briefly, what are the benefits of using expression versus declaration? It seems like declaration would always be a better way to go.
Unless you're in an if loop and you can't use a declaration. Right. So like for example, if I'm something like say, say hey, if var bar equals true. Nope, that's not what I want to do. Okay, cool. I can have a console log out, something like hi. Why does it not like me? All right, whatever. Cool. Okay, so this works, right? If I want to say, hey, console.log out foobar. If I say something like, like foobar is equal to 6, and I run this works totally fine. And if I say, hey, if foobar equals a function that takes in a num and then, does nothing, it tells me, hey, foobar is a function, right? But if I wanted to declare this function, if I try to do this, I can't do it. And the reason why is because this function needs to be evaluated at the highest level.
Right.
And
you can always define it outside the if loop and then call it inside the loop, right?
Well, unless I mean, think of why we use like an if scenario, right? Like what if I want, if this is true, I want this function to become one thing, right? Function, like hi to be one thing. But then and then this, console.logs out hi, right? But what if I want it to be like another function if it's not true, right? They want it to be by. I now have a split condition now where I have this function called hi that I want to use it, but what that variable is going to be dependent upon other conditions, right? So this is illegal JavaScript. You're going to get warnings everywhere, but the way around is to say, hey, cool, if that's the case, let's just do this, right? I'll add a var hi here. And now when I run it, that's because it's not longer exists. And now when I run it, depending on what it is, I'll be able to kind of, my hi variable is now flexible. It can be one of two different functions, depending on what happens outside of it.
Do you have to call it on the other side of the function?
I'm sorry?
Var hi equals function hi, or is it var hi equals function?
This name here is really optional at this point now. I could have it here or I could not have it here. Either way is totally good. JavaScript doesn't care about that at this point. Right. Cool. Cool. Actually, let's call this by and let's just try here, right? Let's do by. Okay, guess I can't do that because I'm declaring already. Never mind. Cool. All right. But yeah, so this is like a scenario in which if you want the function to be flexible or you want to define it based on certain conditions, guess what? You could only use the expressive way of declaring it inside of anything but a function scope. So that's one kind of limitation of this, right? You're right. In general, declarative is a lot better because if it's on the top of the page, you no longer need to worry about like, oh, which line does this come in on, and where does everything else come in on? But in some cases, it's just not feasible. The other thing about this is this could or could not have a name. If it has a name, then it's a function. If it doesn't have a name, it's called an anonymous function. So you'll hear anonymous function quite a bit. All that means is, hey, it's a function I don't actually assign a name to. And usually those are more for functions that are used kind of very transactionally, like, hey, I'm just going to use you once, and then I'm done. Like I don't need to like keep a reference to you to store it anywhere else. It's like I just need you to do this one thing for me, and then you're good.
You don't even have a variable. You just say var function num without the 2 plus and equals.
I'm sorry.
No, sorry. No, what did you say? I'm not.
Sure. What I'm saying here is right now, notice how this is just function and a num, right? There's no name inside of here.
Right.
You could have a name inside of here if you wanted. If you have a name, it's called a named function. If you don't have a name, it's called an anonymous function. It's called an anonymous function because
Yeah, what is the anonymous part? It's a bar equals function of num or bar equals
Sure.
function of
So let's take a look at so let's talk about anonymous functions really quick, right? So let's just say we have a this is gonna be high first. I'll delete the else statement because it's obviously good. Or I can just do this. Okay, so if true, which is always gonna be true. Let's just say I have this function by I'm trying to think what's a good way to demonstrate this principle. But essentially, think about it this way, right? If I don't have this name here, or if I have a function that's not named, for example, and I say, hey, like high equals this, and then I say high equals 6, right? Very valid. But, and this is why you might want to name it in certain cases, is because now that I've reassigned high to 6, I completely lose reference to this function. Like I can't say, oh, I have another variable. Can you capture the old value or the old function? I'll say, what old function, right? It's kind of like once I move away from it, I lose it. So it's anonymous in the sense that usually these are for more transactional functions that you don't want to keep a reference to. Does that kind of make sense?
Yeah.
Cool. So yeah. So anonymous functions and name functions they're nuanced. Like in general, I think as you start coding, you'll intuitively have a very good sense of kind of, oh, do I want to keep a reference to it? Do I want to use it somewhere else or not, right? Once again, functions, definition, a reusable chunk of code. So if you don't plan on reusing it or you don't plan on using it anywhere else, it's probably fine to just, declare it once, use it, and then, even if you lose reference to it, you're not heartbroken because, you're not exactly looking to reuse it in other places. But in general, I think declaration is probably the more popular one. Function expression is obviously totally valid as well in almost all cases. Cool. And then talks a little, and then we jumped a little bit, but this is talking about hoisting, right? So hoisting, once again, just means think of it as JavaScript going through the code twice. The first time is just to kind of see what's there to be available to be used, and the second time is you actually executing the code line by line in sequential order. Order does not happen in the first pass. It's order, in the first pass, it just literally looks on it, and because it knows nothing's going to change in between the first pass and the second pass, it's going to say, hey, what do you have? And we give it all the things we have. It's like, great, now let me run the code, right? This is why, you can't do it with a variable, right? Because depending on which line you're on, that variable could very well change. On line 6, it could be a function. On line 7, it could be it could be like a Boolean or something, right? So that's why, that's one explanation for why potentially expressive functions are not hoisted. But yeah. And then last part, once again, just to belabor the point, function declarations. You can't use them inside of anything but the function scope. If blocks, no. While loops, no. For loops, no. Only function scopes. Basically, that just means your immediate scope, the immediate curly braces around you, must belong to that of a function. It can't belong to an if statement or a while statement or a for loop or anything else. Any questions so far? Fun functions, yay. This kind of makes sense, right? It's kind of brings a little more color to what we've been doing. Because I think so far, a lot of what we've done in JavaScript, it kind of makes sense if you don't think about it too hard. You just kind of take for granted a lot of things work and they just do. And now we're kind of peeling that back to say, great, why does this work, right? Why does a function do this, or why can't I use a function before it gets to it in the line of code? So now we're just kind of filling in a little bit more of the technical blanks. So I'm just going to go through all. Oops, too fast. Cool. So parameters. Parameters are essentially just and this is so. The point of the next 3 slides are going to be to differentiate for you the difference between parameters and arguments. Personally, there's a difference there, but for the most part, you don't need to stress over specific nuances. I think when you talk to people, you'll have a pretty good sense of what they're talking about. But essentially, parameters are what are inside of the functions, right? So in this case, the coffee price and tax is expecting two things. It's expecting the price of a coffee and it is expecting a tax, right? Outside of those functions, you can call those variables whatever you want. They could be called, like super awesome coffee price and then like really bad New York tax, right? You can call them whatever you want. But but once you pass them inside of this coffee price and tax function, they will now be known as, very plainly, tax and price. And every single function that every single kind of use of these two variables now are going to be based on this tax and this price variable. So arguments basically say, hey, initially when you write it out, like this bullet here is sitting at, you have no value. But once you invoke this function, it means you're giving it values, and now these parameters actually have values. You can pass in multiple. Multiple parameters, as you can see here. Just make sure you separate by a comma, so that the JavaScript knows, hey, you're expecting multiple things here. And then finally, you want to name these like. Don't go overboard, but they really should be as explicit as possible, right? Like one of the many bad practices that people sometimes starting off programming have is like making the variable names really short because you type less. So they have things like var a equals this, and then var I equals this, and then var x equals this. And it's really, really great if you're dealing with functions that don't go past like 10 lines, right? Which is probably not going to be very often if you actually work on this like full time. And so you really want to make this as easy to read as possible because guess what? Down the road, at some point, you're going to forget almost entirely that you wrote this code. You're going to go back and look at it with fresh eyes. You're not going to have any idea what the variable names are. So having good variable names is great for you, and from first-hand experience, just makes life so much easier for anyone else who comes after you who's going to have to read or do anything with your code. Just makes it so much better. So the parameters are what's inside the functions, and then the arguments are the actual values that we're passing into the function. So here, the argument here are two things. They are what? 8.9 and 5.0, right? Those are the arguments. Those are the values I'm giving to this function. But once it's inside of here, that is no longer 8.9. That is now called, either they have really weird tax rates or they did this backwards. But essentially, that is no longer 8.9. That is now tax, right? This is no longer 5.0. This is now a variable called price. And inside of here, in between this first line and the second line, what we're really doing is we're just saying, hey, var tax equals 8.9, var price equals 5.0. Like we're creating this variable so you can use inside this function scope. But really, like this is just explicitly just kind of telling you that, hey, don't call it 8.9, don't call it 5.0. You will now know it by these variables. So parameters represent values in a declaration. Arguments are what gets passed into the actual function itself. And then lastly, this part here, which is really ironic because I think they got this backwards, right? Tax divided by, oh, actually no, that's right, hold up, I was wrong. Oh, they just did 8.9 as like the tax rate, okay, my bad. It has to follow the same order, right? Like the first argument is always gonna map to the first parameter. Second argument maps to the second parameter, and more or less like, I forgot in what scenarios it's going to break for you, but in general, those two should match. Like the number of arguments should match with the number of parameters you have for a function. Any questions on arguments and parameters? It's kind of like what goes in, what comes out kind of thing. Yes?
So limit to the amount of arguments or parameters you can have?
No, not at all. You can call as many as you want. One thing that one practice that I've seen is that if you have like 30 parameters, it might be good to put those in an object and passing that object into the argument. Or sorry, pass that object as the argument. So what I mean is like, let's just say here where it's like, like if I have something like, if I have a function foo, and I want to pass in like var1, var1, var2, var3, so on, so on, so forth. What I really should do is I should just say, hey, have this thing called var obj equals this, and I'll just, and I'll have something like var1 here, var1, right? And so here I can just pass in obj, And then inside of this function, I can now access whatever I want. So I can say, hey, like var fun is equal to obj index of var1. Kind of a janky example, sorry for that, but like,
What's the colon in your variable name? Or your, the colon in your object name?
yeah, this basically denotes this is the key and this is the value. So if I have something like var1, speaking of bad variable namings, so let's say this is David, and if I console.log out typing while standing up is surprisingly harder than you think. Just throwing it out there. God. Okay.
You can raise the desk.
I can raise a desk. Oh, that's true. Yeah, so basically this colon just says, hey, this is the key, and this is your value. It separates the two.
And the key is the name of the value, or?
Yeah, think of like an object. It's also called a dictionary in some other languages. Like the key is like the word, and then the value the definition. So usually people want a definition, so they say like, oh, tell me what this thing is. And you say, oh yeah, that's stored under this word or under this key.
Would a key also be known as a property?
The thing is that like as kind of languages somewhat converge, like most languages like steal pretty aggressively from each other. Like they take the best parts of each other's practices, which is like totally fine and fair in the spirit of programming, right? As these languages kind of borrow a lot from each other, you'll hear a lot of terms get thrown like quite like interchangeably, even though they may not be explicitly so. So like an object is also known as a dictionary. In Python and in Ruby is known as a hash, right? So and all three are more or less like identical, like the same thing. Python instead of arrays, you have something called lists, right? There's a few other ones too, but yeah. Oh, and then like null, I think is like it's none in Python and it's nil in Ruby. So like every language has their own like little like quirks on how things are implemented. But for the most part, like I think it kind of makes sense, right? So when I say things like this is a list, that's probably me being a bad JavaScript instructor in terms of leaking other languages in, but hopefully it kind of makes sense to you. It's like an object is the same as a hash, it's the same as a dictionary, and then a key is the same as a property. And I think there's another name for it that's I'm blanking on right now, but yeah. But cool. So yeah, so to answer your original question, we kind of deviated from it, right? Is that if you ever find a situation in which you have like a bunch of different variables, rather than maybe calling it explicitly, you can group those arguments into an array or an object, and then just pass that one thing in, so that when someone looks at your function, it's still kind of clear what they're getting in terms of, oh, they're getting an object, and oh, look, these are the properties on the object that I'm accessing. So yeah.
Okay, so the first part is called the key, and then everything after the colon is called the property?
Sorry. Everything to the left of the colon can be called either the key or the property.
Okay.
Everything to the right of the colon is the value.
All right. We're going to get into this more later, or?
Yeah, we'll have a whole section on objects. They're pretty fun depending on how you look at it.
Sure.
Yeah, one thing you also hear is like a key value pair, like that term thrown a lot. That's just what this is, right? It's like a pair of a key and it matches to a value. That's pretty much it. But yeah, we'll talk more about objects later on. But yeah, this is just to show that, like, if you have a lot of arguments, sometimes, most cases, it's a good idea to group them in first before you pass it in as an argument. So just so that like you can save yourself typing and it makes it a lot easier for the person coming after you to kind of figure out what's going on. I mean, a lot of the things we do in programming are really just to make it look cleaner and easier to understand for the people coming after us, right? If it was just computers reading this code with each other, like you can make it as complicated as you want. Computers can handle it pretty well. It's kind of like for our benefit to actually group them together in more elegant manners. Cool. Any questions on arguments and parameters before we move on to the last part of this lecture? And I'll have a much bigger, more awkward pause for questions when everything's over, and 2 more slides. Cool. So, what's wrong with this code here? What is sum going to be when printed out on the very last line?
Undefined.
Why is it going to be undefined?
You didn't return anything.
Right. Because this function right here it does this really cool operation. It adds these 2 numbers together, and it's like, okay, I'm done. And like, okay, that's great. what now? And it's like I'm done. Like I finished adding up my two numbers. I'm finished. So then what happens is, and I think we covered this already, but what happens when you don't return anything in a function? I'm sorry? Right. What does it return when you don't return anything in a function? Yeah, I mean, as maybe guess, it's undefined. So in any function, if you don't return anything automatically, it will return undefined for you. Like you'll never see the word return, but it's going to return undefined every time. If you don't have your own return statement, it will return undefined. Which just so you guys know, for like fun, like Ruby does it slightly differently. What Ruby does is it returns the last thing that's evaluated, which is also like its own little like vortex of confusion. But basically, the last variable that you like modify or express really, that's what gets returned. So in JavaScript, just keep in mind that your function is always returning something, and if you don't tell it what to return, it's going to return undefined. Aha. And this is how we solve it. Just very simply return it. Okay? I stressed this on day one, and I can't stress it enough. Returns and console logs, fundamentally different things. Logging it literally means I want a human to read it. It has zero practical value on the code whatsoever. You can say, well, David, my code is returning back like, 1 plus 2. And I'll say, no, it's console logging at 1.2. It's just telling me what it is. It does not return anything. If I was to capture the output of a function that only console logs, what is it going to capture?
Say that again?
If I have a function that only console logs something, what am I going to capture if I'm trying to capture the output of that function?
Nothing.
Undefined. Exactly. Remember, every function is going to return undefined. If I have a function that only console logs, it's going to return undefined. If I have a function that only evaluates things, it's going to return undefined. Until I tell it very explicitly what to return, it's going to say, I'm going to give you back undefined no matter what. And so console logging and returns, fundamentally different. Don't confuse the two. It's like, it's hard because I think like visually we see, oh, this logs out. It must be what gets back. But to a computer, the only thing that matters is what actually gets returned. Nothing else really matters to a computer. And least of all, console logs. Cool. All right. So the return statement is used in a function. Pretty straightforward, right? And what this really means is that like if I try to return something on the page directly, it's most likely not going to work, right? Because they're like, well, there's no function to return this from or return this out of, however you want to say it. The other thing about a return statement is, as soon as JavaScript, like after it hoists everything up, right, it goes through it line by line sequentially, executes a line by line. If it hits a return, it will finish that line, and it will stop. Doesn't matter what you have after it, it will stop. It will not keep going. Okay. So in this case here, we have a return, then we have a console log, and as this print statement was nice enough to tell us, this line of code will never ever ever run. Because as soon as JavaScript goes and hits that return, it will say, great, I'm completely done with this function. Nothing else after me is going to matter. Okay? So that's why return statements are almost always placed, if not the very bottom. I mean, really, it's only placed at the bottom, right? Because if you think about it, like, what's the point of having anything else beneath it? It's not going to run, right? So return statements are almost always going to be the very last line of your function. Another nuance. If I have a function and I have like a for loop, right, or an if statement or a while loop in there, and in one of those I return something, guess what? Let's say I'm looping over a list of 5 things or an array of 5 things, right? On the first item, I say, oh, return true. Guess what? Not only does the for loop stop, the function also stops. Return basically exits you out of the nearest function that you're in. So if you're in like 10 nested loops, 10 nested for loops or if statements, doesn't matter. It will find the nearest function. It will say, great, this function, you're now shut down. I'm giving you back whatever you told me to return once. So in that example, where I'm looping over something 5 times, it will run the first time, and it will never run the next 4 times. And in fact, nothing else in that function block is going to run once I hit that return. So always be sure that whenever you have a return anywhere, just be conscious of the fact that you're telling this code, once you get here, stop. You have nothing else to do. You're done with this function. Okay. And I think that's pretty much it. Cool. Yeah. I mean, you'll get the examples yourself. But But yeah, any questions on anything about functions regarding arguments, parameters, returns, invocation, and hoisting? So all pretty big concepts. Any questions at all? I'll be here for probably at least 30 seconds. Oh, sorry. Totally. You just yell at me.
Okay. For the named expressive
Yep.
functions, I was just wondering, like, so you name it inside, say, a function, how, or a nested function, no, or I guess nested inside a function. How far up can you call it back that named function when you like change the name of the variable? I guess is that scope or is that what?
Right. So, okay. So maybe I did not do a great job of explaining this part. So your question is like,
Or maybe I missed. I'm sorry.
no, I'm almost certain it's because I didn't explain this well. So let's just say I have something here. It's called like var high equals, right, and I have a function here. So basically, you're saying like I have a function here that takes in whatever and then console logs out whatever. Cool. Okay. Or actually, you know what? Let's just return nothing. Okay. That perfectly valid JavaScript. Cool. And then here I'll console log out high. Cool. Okay. So notice the undefined here. This now makes a little more sense, right? This is JavaScript. It's saying, hey, you execute a function, it return undefined. Here you go. This must be what you wanted. Cool. So actually, let me see if I can do. REPL might not let me do this. Okay, yeah. REPL doesn't do this. It's like it's janky. Anyway, cool. So your question now is basically, if I now say, hey, high is equal to something else, how do I maintain accesses by variable, right? And so in general, like what this is actually doing is you actually, I think you pretty much lose track of this by variable. Let me double check this for you though, just to be sure. By, if I want to see it, pretty sure we lose function. Okay, yeah. So basically when you do this, like you just lose, like when you define it this way, like you're basically pinning this function on the fact that you're assigning to a variable name, right? Once a variable goes away, you lose entirely. Whereas if we were to do something like, if I just take this here, right, I say, hey, you know, very valid JavaScript, I'll put it up here now. And now if I console log out by, it will just say, hey, you're an empty variable called by. And so like declaring it like expressively, it basically means I'm assigning to a variable and I'm pinning it entirely on that variable. Giving it a name means if I declare declaratively with the name, I now have a reference to this name anywhere else. So if I say something here like, hey, now you're set to by, and I console log out high at the very end now, you'll see that this is maintained. Cool. So if you have a function and you want to be able to use it again, and you're worried about reassigning the variable, declare it declaratively. If you do want to store it in a variable, you want to keep track of it as you go through it, then use a variable for it. The other reason why people like it is, and this is like I guess not nearly as solid of a reason, is just because like if you wanted to create it anywhere, you want to have able to pass it back and forth. Like sometimes like a variable is more handy, especially if you want to create it only under certain circumstances. So like the whole if loop scenario we saw earlier. But for the most part, like if it's a piece of code you're interested in reusing it, either store it in a variable or declare it declaratively, right? And if you do it expressively, just realize that you're always running this risk. Because right now, if I say high is equal to 6 down here, I can definitely not that. I can still console log out by, and it's like perfectly valid, right? It still exists somewhere. Storing in a variable just means you'll lose reference to it forever. Same as anything else, actually, right? Like if I have something here, it's like, hey, I have an array of 1, 2, 3, and then I say high equals 99. I pretty much lose reference to that 1, 2, 3 array like entirely, forever. I can't really get it back. So same idea here. One, 2, 3 is gone. Sad face. Oops. Any other questions on functions? Thanks. Everyone feels really good with functions? Pretty good? We'll see about that. Cool. Awesome. I will create pairs. Feel free to take a break, and I'll Slack it out. And then whenever you and your partner get back and want to get started, get started.